We're going to talk about volume of three-dimensional figures today. What I have here is I have a chart that has all of the formulas in it, and yes, you can use the formulas on your test. Most of the standardized tests will give you these general formulas, but they will not give you like what big B is and whatnot, and you have to know what the letters mean. So let's talk about volume of a prism. So remember, prism, this big B, means the area of the base. Remember, the base could be anything. It could be a triangle, it could be a rectangle, it could be, I don't know, a hexagon. You find the area of the base, and h is the height of the prism. Then, a cylinder. Volume equals pi r squared times h. Remember, r is the radius. Then h is the height of the cylinder. For pyramids, we have volume is equal to 1/3 big B times h. Again, big B is the area of the base, and h is the height of the pyramid. Then we have the cone. Volume is equal to 1/3 pi r squared h. R is the radius again, and h is the height of the cone. And lastly, sphere. We have volume is equal to 4/3 pi r cubed. And remember, the only thing you need for spheres is a radius. And just so you remember the diameter is equal to 2 times the radius. Alright, so let's do some examples. We're going to be referring back to these formulas. So, first, example 1 says find the volume of each. What we have here is we have a triangular prism. So, the volume formula for a prism is V is equal to big B times H. So, H is going to be the height of the prism, and then big B is the area of the base. Now, the base in this case is a triangle. So, the area of a triangle is going to be our big B, and that formula is 1/2 little b times h. Now, little b is the base of the triangle, not the base. It's not referring to the same thing as big B. So we got to find the area of this triangle. What I'm going to do is I'm going to pull out this triangle and draw it. I'm just going to sketch it. And I know that both of the sides are 12 and the base is 10. So we don't actually have the height. What we need to do is drop an altitude, and we're going to figure out what that is, what that height is. Now, this forms a right angle, so what we have here is we have a right triangle. And if we have the right triangle, we can use Pythagorean theorem here. Now, what this does to this side is it bisects it. So instead of having 10 on the bottom, we're going to have 5 and 5, because 5 plus 5 is 10. So we're going to use Pythagorean theorem and figure out the height. Now, a squared plus b squared is equal to c squared. That's Pythagorean theorem. A squared, we're going to choose that to be a, plus b squared, which we don't know. We're going to call this b, but that is actually the height of this triangle. And then is equal to the hypotenuse squared, which is 12 squared. So 5 squared is 25 plus b squared, and then is equal to 144. Then we subtract 25 from both sides. You get b squared is equal to 119. Take the square root, and we get little b. We're just going to use one decimal place, 10.9. So the height of this triangle is 10.9. So I'm going to plug into this formula so I can find out the area of big B. So that's equal to 1/2. My little b is 10.9. Actually, it's not. My little b is 10 times my height, which is 10.9. So when you put that in your calculator, you get 54.5. Okay, so now we can go back to this formula and we can plug in. Since we know that our big B is 54.5, we have volume is equal to 54.5 times the height of the actual prism. And the height of the actual prism is 25. Now, be careful. We've got two H's we're talking about here. We've got the height of the triangle base and then the height of the actual prism. So put that in your calculator, and you get that the volume is 1,362.5, and the units is centimeters cubed. Now this is volume, so we're talking about cubic volume. So there's our solution there. Next, we have a cylinder. Now, this isn't just any old cylinder, this is an oblique cylinder. But guess what? We're going to use the same exact formula. Now, you have everything you need for the cylinder. First of all, the volume of a cylinder is equal to pi r squared h. Now, this 27.6 inches is actually the height, and this is going to be the radius. So, same thing here. Let's plug in. This one's pretty straightforward. It looks complicated, but it's not bad at all. So, radius is 13.2. And we're going to square that times the height, and the height is 27.6. Now let's put this in our calculator, and now make sure you use the pi button and not 3.14. And for this, you get the volume as 15,107.99. So let's round this 7 to 8. And our units, inches cubed. So even though that one looks a little bit complicated, it's actually one of the easier ones. Moving on. Here we have a pyramid. We have a rectangular pyramid. We got a rectangle on the bottom. So the volume for a pyramid is 1/3 big B times h. And remember, big B is the area of the base and h is the height of the pyramid. Okay, so we have the height of the pyramid. The height of the pyramid is 10.5. So we need to find out what the area of the base is. So I'm going to go to the side, and big B is we need to find the area of the rectangle. A rectangle's area is length times width. So if we're looking at this rectangle down here, we're going to multiply 8 and 6. So we get that the area of the base is 48. So that was pretty straightforward. So we're going to substitute that in for big B. So for our formula, volume is equal to 1/3. We have 48 for big B, and the actual height of the pyramid is 10.5. So let's put this in our calculator, and we actually get 168. And the units are meters cubed. Let's move on to our next example. Here we have a cone. Now the volume for a cone is equal to 1/3 pi r squared h. Now we have our r, but we don't have our h. But what we do have is we have our slant height, which we don't need for this formula, but it's just nice to point out that that's actually our slant height. So what we have here is we have a right triangle, And we can use the Pythagorean theorem to figure out what the height of our triangle is, which is the height of the cone. If you notice that you're going to use Pythagorean theorem a lot. So I'm going to pick 3.4 as my A plus little b squared, which is my height. And that's equal to 8.2 squared. So 3.4 squared is 11.56. 8.2 squared is 67.24. Then we're going to subtract 11.56 from both sides. Then we get b squared is 55.68. Then square root. And you get our little b, which is the height, is 7.5. Okay. So now I've got everything I need to plug into this formula. So I have 1/3 pi times 3.4 squared times 7.5. So let's put that in the calculator. And from this, get 90.8. And my units are centimeters cubed. Got one more example. We're going to do a sphere. Now, the formula for a sphere is 4/3 pi r cubed. Now we need the radius, but what we're given here is the diameter, but that's okay, because all we have to do the radius is split it in half. So our radius is 4. So let's plug into our formula. Spheres look complicated, but they're actually pretty easy. Now, don't forget, this is a cubed. A lot of people will make a mistake because we've been doing squared, 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 that they don't do the cubed. So let's put this in our calculator. Make sure you use parentheses around your 4/3. And for this, we get 268.1, and our units are meters cubed.